This is R.D. Sharma solution, class 12, chapter 10, differentiability. MCQ multiple choice question we are taking. This fx is ax square plus 1 when x is greater than 1, and we have to check the derivability at x equals to 1. When x is less than or equal to 1, it is x plus 1 by 2. Right? For those who want to do by themselves, they have a reference here. That is the answer I am showing. And derivability is, that means we have to do the left hand derivative and right hand derivative, and since it is already given that it is derivable, so we can just equate the LHD and RHD. So in order to understand this, this is x, this is 1 where the point of contention is, where the graph is supposed to be changing. So this 1, you go left, you go right. When you go left, you will take x plus 1 by 2. When you go right, you will take ax square plus 1. Okay, on the right hand side, ax square plus 1 is the function. On the left hand side, x plus 1 by 2 is the function. So we'll place 1 minus h on the left, 1 plus h when we are taking the right hand derivative. So LHD and RHD, because we are checking the derivability. So this LHD, RHD, so the functions, the actual function, which is fx minus fc by x minus c, limit x tends to c. So c is 1 here because we are checking at 1. f1 is what? Where is the equality? It is here. This is the equality. So we have to put this 1 in x plus 1 by 2. So 1 plus 1 by 2 is 3 by 2. f1 is 3 by 2. So this fx minus 3 by 2 and divided by x minus 1. This is a simplified version which I made, and we are going to put fx depending upon left and right what we are taking. Here the fx has to be put what? If you go to the left, it is x plus 1 by 2. So limit x tends to 1 minus, that is on the left. This 1 minus represent you are going to the left of 1. A bit number, a small bit which has to be deducted. So x plus 1 by 2 we are going to use. 3 by 2 is already there. Denominator is x minus 1. I am also writing this the right hand derivative, but I'll just take it in a short while. So ax square plus 1 is the function we are going to employ, and x minus 1 in the denominator. Okay, half minus 3 by 2 is what? It's minus 2 by 2, that is going to be negative 1. So what we get here is half minus 3 by 2 is negative 1. So x minus 1 here. Now x minus 1 in the numerator, x minus 1 in the denominator, it gets cancelled out. So you'll get a 1. So you get a 1 if whether you want to put 1 minus h or whichever value, because it is a constant function now, 1 you are getting, so you don't have to worry about the value will be 1. So left hand derivative has given us a value after putting or without even putting the 1 minus h. Taking the function, this we got as 1. Now left hand derivative we have already taken, and that has come to 1. Now coming to the right hand derivative, and if you remember fx minus 3 by 2 divided by x minus 1, that was the simplified version I told you. This is minus 3 by 2. So fx on the right, when you have x greater than 1, so on the right you are going to take ax square plus 1. So we'll put x as 1 plus h, the way we were trying to put 1 minus h, but it was of no use. So on right we have to put 1 plus h, ax square plus 1 minus 3 by 2. So limit x tends to 1 plus it is. In the denominator we have x minus 1. So in place of x, replace it by 1 plus h, and then limit h tends to 0. You have a. In place of x, put 1 plus h whole square. So 1 minus 3 by 2 is, this is going to be negative half. Okay. X minus 1, so 1 plus h minus 1, this gets h. Okay. Now this if I open it, just to give you an idea, if I just open it, a 1 plus h whole square, that is a square plus b square plus 2ab, 1 plus h whole square is this. So you get a into ah square plus 2ah, and minus half it is, and divided by h. So can you take anything common? No, nothing, because h is in the denominator. So if you put h as 1, here, because no, you cannot put it as 1, you have to put it as 0. But you know a left hand derivative, right hand derivative has to be equal, so it has to be equal to 1. Now open this, a plus ah square plus 2ah minus half divided by h is equal to 1, limit h tends to 0. I am taking h on the right hand side because now the LHD has to be equal to RHD. So a plus ah square plus 2ah minus half is equal to h. Now we already have limit h tends to 0 on both the sides. So you can just apply the limit here. This also holds true, limit h tends to 0. So you have a plus, here it is 0, then 2ah is 0, minus half, and this h is 0. Now what do you get? After applying the limit, a minus half is equal to 0, so a is equal to half. So a will be 1 by 2, then this will be derivable at x equal to 1. This function, see, x minus pi, this is a greatest integer function, and greatest integer function always give you the floor value. And we have already talked about this sine theta and a constant function. We know that both are continuous and differentiable everywhere, but where they are not, let's see where they are not, or whether they will be continuous and differentiable. So anything divided by 0 is not of our use, it is undescribable. We don't take this as an option for the continuous and differentiability. So anything should not be dividing by 0 at any cost. So we have to consider the denominator more, you can say, with more observant attitude. This numerator you already know, sine theta, when theta will be equal to 0, when it is equal to n pi. So what is given here? X minus pi into pi, and x minus pi is the greatest integer function. So this is n pi, and when you just cancel this pi, you will get x minus pi equals n. Okay, so x minus pi equals to n. So the value of x minus pi will always be some n, right? And this n, I am saying that this is an integer. N pi is integer only. X minus pi is integer. So this is x minus pi is n into pi. The only thing when it is going to get 0 is these points. Okay. So there is no problem here. But the denominator 4 plus greatest integer function whole square should not be equal to 0. So greatest integer function will always give you a value which is integer, because this graph, let me make it a correct graph, 0, 1, 2 like this. This is a number line. Always the greatest integer function will give you an integer value. That is, it will always be some value here as an integer, 1, 2, 3, minus 1, minus 2, minus 3. But this is square, in question it is square. So when you square negative 1 whole square, you will get 1, you will get negative 2 whole square as 2, right? So you will always get a value minimum as 0, and more it goes up to infinity, all the integers. So minimum is 0. So this will be, this cannot be 0 at all. In order to get 0, you have to have this greatest integer function as square as negative 4, and that is not going to come at all. Never, because it is square of a negative number. So the fx is a constant function, it is continuous and differentiable everywhere. Let fx is equal to a plus b into modulus x plus c into modulus x to the power 4, where a, b, c are real constants. Then fx is differentiable at x equals to 0 if. So the differentiability already given, the fx is differentiable. So you can do it by yourself. You just have to take the left hand derivative, right hand derivative, just equate it. And by equation, you will get some value of b or a, whichever is there. Modulus x, we already know it is x when x is greater than or equal to 0, negative x when x is less than 0. So this function, you can just say that when x is, because we have to check at x equal to 0. So when x is greater than 0, you are going to get some value. What value you are going to get? All the modulus x you have to put as x or positive x. When you have x less than 0, then what you are going to get? All the modulus x will be negative. So a minus bx, but since it is modulus x to the power 4, the third term, it will be positive, not negative. I hope you got the idea, because the power is 4. Even power will always give you a positive value. Positive, negative will be positive then. So left hand derivative and right hand derivative we are going to find out. So I'll just make the function simplified. Fx minus fc by x minus c is our actual function for the derivability. So fx minus fc, we have to check at x equals to 0. So x is 0 minus h here, that is negative h. X is 0 plus h on the right. So you can write it as h. So fc is what? Where is the equality? This one, a plus bx plus cx4. So f0 will be a plus b into 0 plus c into 0 to the power 4. So you will get a here. So this function becomes fx minus this a divided by x minus c. So we have to check it as 0. So c will be 0. So divided by x. So fx minus a by x, this is what we are going to use. This is a simplified version. When you are on left of 0, you are going to use a minus bx plus cx4 minus a divided by x. On right, you have to use a plus bx plus cx to the power 4. And that is subtraction of a divided by x I am writing. But now I will put x as negative h on the left and positive h on the right. So limit x tends to 0 minus here, limit x tends to 0 plus here. So this is only showing that where we are going, on the left or the right. And then we have to equate it also. So just put the equality in between these two, because they are equal. This function is differentiable at x equal to 0. So this limit x tends to 0, I am putting x as negative h. So a into minus b minus h plus c into minus h to the power 4 minus a divided by x is negative h here. Just replace it by negative h. On the right, we get limit h tends to 0. Again, just replace x by h. So a plus bh plus ch to the power 4 minus a divided by h. Right? Now, since the function is differentiable at x equal to 0, which is already given in the question, so this h you can cancel. You have equated now. And now you can just apply the limit. Limit h tends to 0, you can just apply. You get a minus minus become plus bh, minus h to the power 4 is plus h, so it will be ch to the power 4 minus a is equal to, this is a negative outside, okay, we have a negative here, so we'll just take this negative. So you can have it a negative here, or you can just transfer this negative on the right hand side. It's up to you. We'll just see how does it turns out to be. It's negative a plus I'm just taking the negative on the right. So minus a minus bh minus ch4 minus a. So I multiplied this negative which was on the left on the right. You can do either ways. You can multiply this on the left also. So now apply the limit. I'm not writing it limit h tends to 0. You are applying the limit now. So this minus a plus a plus a, this gets cancelled. Now bh plus ch to the power 4 equals minus bh minus ch to the power 4. You can take h common, you get b plus ch cube. Then on the right you can take h common. So you have minus b and minus ch cube. This h gets cancelled. Now apply the limit now. As I am saying, limit h tends to 0 is already there. So wherever h is there, that term you can cancel out. I'm applying limit h tends to 0 here also as well. You are left with b here, you are left with negative b here, b minus b. So you can take 1b here, 2b equals 0, b is equal to 0. So this is your answer, b is equal to 0. Now this question is a bit tricky. Why? Because there are various solutions available, and some of them they have given different discussion. And modulus 3 minus x is quite easy to understand. You have already done a question like this. But here we have a least integer function. So you are talking about the ceiling. The greatest integer function tells you the floor. The least integer function will tell you the ceiling. But the problem here is all the solution they have considered this x only as x round x, means the greatest integer function of x, but it is not. The greatest integer function is 3 plus x. The whole is 3 plus x. Then we have a round bracket, and that round bracket is suggesting it is the least integer greater than or equal to x. Okay. So we'll put x as 3 minus h and x as 3 plus h. What we have been doing, we have to check at x equal to 3 because all the question is options are at x equal to 3. So x equals 3 minus h on the left, x equals 3 plus h on the left. So we have this 3 minus h, just replace this wherever x is by 3 minus h. So we have plus, this is 3 plus x, so 3 in place of x, just replace it by 3 minus h. 3 plus 3 minus h. But remember, this round bracket is not a simple round bracket. It is a least integer function. Now limit x tends to 0, and right hand also, to check the continuity, we'll just check it. So we just have to put 3 minus in place of x, put 3 plus h, and plus here again 3 plus x. So in place of x, replace it by 3 plus h. Please remember, in the greatest integer function, you always, whichever is between n and n plus 1, you'll always get an n. But when it is greater than or equal to, that means the least integer, you'll always get n plus 1. So this 3 minus h will be what? 3 minus 3 plus h, 3 gets cancelled, you have h here. So modulus of h plus 6 minus h. And this is, you can put a square bracket, you can put a round bracket. On the right, you get limit h tends to 0, 3 minus 3 plus h. So you get negative h here, negative h modulus. And you have this 3 plus h. So 6 plus h you'll get. Okay. Now, you can apply the h tends to 0 easily at the modulus function. That we have already seen. Modulus of 0 here and modulus of negative 0. This is quite easy to contemplate. But this great least integer function, we cannot put h as 0. Why? Because 6 minus h will give you something, and we have to take the least integer function of that value. That is, you are at 6. You are subtracting something from 6 minus h. So it will be the least integer function will always give you a higher value. Okay. So this 6 minus h will give you 6. And I've written this 5 as wrong. It is going to be 6, sorry. So there is a slight mistake here. You will get as a 6 here. And on the right, 6 plus h, of course, 6 plus something h will take you to 7. So 6 and 7 is not equal. Please remember, 5 is wrong here. I am saying it to be 6. And why 6? Because you have subtracted something from 6, it will always go to 6. You add something to 6, it will always go to 7. So 6 is not equal to 7. And since it is not continuous, it will not be differentiable. Okay? I hope you got the idea. See, if you have to do this 2 to 3 and 3 to 4, you put something which is lower than 3, that is 2.9, just higher than 3, that is 3.1, the concept remains the same. So rather than doing this as 2 to 3 and 3 to 4, or x less than 3 and x less than greater than 3, the better way is to directly put the way I showed you. And there is a slight correction here which I am just reiterating. It is not 5 on the left, it is 6. Okay, it is 6 on the left and 7 on the right. And 6 and 7 are not matching, so it is not continuous. But it is differentiable, but it is not differentiable since it is not continuous. You have to have continuity to get the differentiability. Okay, so it is not continuous. You can just say it is not continuous, not differentiable as well. This is how we understand. Again, I'm sorry for this 5, this is 6. So in order to solve this question, there is one thing which you need to keep in mind. There's only one catch here or hack here. e raised to the power 1 by x it is. So if x is 0, e raised to the power 1 by 0, 1 by 0 is infinite. Anything divided by 0 is a very huge number. We don't know that. So e raised to the power infinity, because e is 2.72, like that number, e is, we know it has a proper value. So that to the power infinity will be infinity. Infinity is a very big number. So we will put x as 0 minus h on the left. We will put the x as 0 plus on the right. So continuity, in order to check, let us see. We will put x as negative h. We will put x as positive h in this function. So 1 by 1 plus e raised to the power 1 by x. And I am directly writing minus h because we know what are the steps, what you are going to write. I'll show you the solution also so that you can try it yourself. So limit h tends to 0 on the right. So you will get h in place of x. So e plus 1 by h. 1 plus e to the power 1 by h. So 1 plus 1 by e raised 1 by minus h. See, x to the power minus 1 is what? 1 by x. So e raised negative 1 by h can be written as 1 by e raised to the power 1 by h. So 1 by 1 plus e raised 1 by h. Now when you apply h as 0, 1 by e to the power 1 by 0 is what? Infinite. H is 0, so 1 by 0 is infinite. E raised infinite is what? Infinite. So what do you get here? 1 by infinite. E raised 1 by h, as I told you in the earlier, when we started this question. Here again h is 0, so e raised 1 by 0 is e raised 1 infinite. So 1 by 1 plus e to the power infinite is infinite only. So 1 by infinite is what? If you divide 1 by infinite number, it is going to be 0. So 1 by 1 plus 0 it is. So it is going to be 1. So this, when you add anything to infinite, it is going to be infinite only. So 1 by infinite is going to be 0. Again, if you divide anything by infinite, it is going to be 0. So on left you get 1 by 1 plus 0, that is going to be 1. On the right you get 1 by infinite, that is going to be 0. So the left hand limit is 1, right hand limit is 0. They are not matching. So the function is not continuous at x equals 0. So when there is no continuity, there cannot be any differentiability. Alright. So discontinuity does not correspond to differentiability. So this is a solution which I want to highlight. There are certain people who want answers. There are certain people who say, oh, you are showing the answer, you are solving it. What is the fun? So, both the audiences I have to feed them. So this is how it turns out to be. You have 1 and 0. So you don't have to check the differentiability. This is an MCQ question. When the function is not continuous, why would you go for differentiability? You don't have to do. Unless and until you are specifically asked, okay, check the continuity and differentiability, then you will do the differentiability. If this question comes in that kind of situation, then you have to do the differentiability that I have already showed you. But if you write that if the function is not continuous, it cannot be differentiable, the examiner will understand. Alright. This question we are going to take in the next discussion. Till then, thank you so much. Take care of yourself.